Good afternoon to one and all. My name is Pushpa Rani, Associate Professor, Department of CSC, MLR Institute of Technology. In the last video, we already discussed about the logical inference by applying the first method called truth table method. But in the case of second method, we need to apply the rules to derive the conclusion. By applying the rules, we are going to use the rules, or it is a laws, that may be so many number of laws we are going to apply to derive the conclusion. If the conclusion is derived from the set of rules, then we can say that it is a valid inference. Otherwise, it is a invalid inference. So, what are the rules of inference? What are the list of rules? And we are taking some examples for understanding whether the conclusion is a valid inference or not. So, we already discussed about the truth table. What is the problem with the truth table? So, truth table is a very difficult one if the number of variables are more. Suppose if there are two statements are there in the preposition, by using 4 rows, easily we can say that it is a valid or it is invalid. Suppose there are 3 prepositions, easily we can get 8 rows. If it is a 5, 32 rows are present. If the number of atomic variables are increased, then truth table technique becomes a very difficult one to check whether the inference is valid or not. To overcome this problem, we are going to apply the rules of inference or not. Before going to check whether the inference is valid or not, there are 2 rules we are going to use in the case of the rules of inference. First one is called as rule P, second one is called as rule T. The name itself is a rule P, the name itself is a rule T. What is meant by rule P? A premise may be introduced at any point of time in the derivation. So, this rule P can be applied at any time. But what is meant by rule P? The rule P is already present in the set of premises. That is the most important point. Rule P is present in the set of premises. Suppose if the problem has given in the set of premises, this rule P is to be applied. For the existent set of premises, we are going to apply the rule P. Then rule T. A formula may be introduced in the derivation. It is logically implied by one or more preceding formulas in the derivation. That means it is a derived premise. That means it can be derived. For example, suppose P tends to Q and P. From these 2 rows, we have to derive Q. It is called as a rule T. That means it is derived. If any premise is derived from the set of premises, then we can call it as a rule T. What about rule P? Rule P is already present in the set of premises. It is already present in the set of premises. But what about rule T means it is derived premises from the set of premises. For this set of premises, we are going to apply the rules to derive the new premise, then it is called as a rule T. So, we need to remember these 2 rules before applying the rules of inference. So, what is rule P? Rule P is already exist in the set of premises. Rule T is applied when the new premise is derived from the set of formulas. So, before going to start the examples, we need to remember some rules of inference. That is a important formulas we need to remember to derive the conclusion. There are some important implications. P and Q. P and Q. We can return either P or it is a Q. That is called as a simplification. That is called as a simplification. Based on the set of premises, we are going to apply the rules. Next. From the P, you can derive either P or Q. From the Q, you can write P or Q. This is called as a addition. Means we need to add extra premise for the existing premise. That's why it's called as a addition. Next, if it is a negation P is present, we can write it as a P tends to Q. If it is a Q is present, we can write it as a P tends to Q. Anything you can write, either negation P, if P tends to Q is present, either you can write negation P or it is a Q, depends upon the set of premises you have to apply the implications. Next, if negation P tends to Q is present, negation P tends to Q, you can write either P, that means you can take the reverse of this one, negation P tends to Q means only P. If it is a negation, this becomes a negation Q, that is a opposite. Just take the simplification. If you take the negation, it becomes a negation normal P, that means negation will be cancelled. If it is a negation, then right side also we have to take the negation, that is called as a I8, implication number I8. These are the set of 8 implications. Next, I9, that is P comma Q. You can write it as a either P and Q. Next, I10. So these I10 to I14, these are the important rules of implication. Most of the time we are going to apply these implications in the derivation of the rules of inference. Negation P comma P or Q implies Q. This is called as a disjunctive syllogism. This is called as a disjunctive syllogism. That means we are going to apply the disjunction between the two prepositions. That's why it is called as a disjunctive syllogism. Next, P and Q. Just for remember, P get cancelled. We are going to get only Q. That is modus ponens. Modus ponens. Next, negation Q, P tends to Q. So Q, then same variable. What about the left out of variable? That is a P. That is the negation P. That is called as modus tollens. Next, P tends to Q, Q tends to R. That is according to the transitive property. According to transitive property, so P tends to Q, Q tends to R, then P derives R. That is called as hypothetical syllogism. That is a hypothetical syllogism. Next, P or Q, P tends to R, Q tends to R, derives R. Derives R. Because P is a common attribute, Q is a common attribute, then automatically derives a R attribute. This is called as a dilemma. So these I10 to I10, I11, I12 is the most important rules of implications that most of the cases we are going to apply these rules. That is a disjunctive syllogism, modus ponens, modus tollens. Next, equivalent formulas. We already discussed in the case of the, that is normal forms. We already discussed about what is a distributive law, what is De Morgan's law. We are going to apply the same laws if it is required. In the case of equivalent laws, either you can apply LHS is equal to RHS or RHS is equal to LHS, depends upon the situation or depends upon the set of premises. Negation P implies P. P and Q is also written as Q and P. This is called as a commutative law, or P or Q is equivalent to Q or P. Next, the same thing we need to take the associative law, just a replacement of the parenthesis. P and Q and R is written as P and Q and R. Just you have to replace the parenthesis. That is called as associative law. The same AND operation is applied for OR operation. P or Q or R implies P or Q or R. That is called as associative law. Distributive law means the variable can be distributed to two premises. That is say P. P is distributed to Q. P is distributed to R. P and Q or P and R. Then in the same way, in the place of one, you are going to take OR operation. In the place of OR, you can take AND operation. P or Q and P or R. That is called as a distributive law. Next, De Morgan's law. De Morgan's law means the negation can be applied either inside of the preposition. If it is already present, we have to take out the preposition. If it is inside, if it is outside, then you have to apply the negation inside of the preposition. We are going to get the negation P. Negation AND becomes OR, that is OR negation Q. Next, again negation P or Q is written as negation P and negation Q. That is called as a De Morgan's law. So P or P becomes is equal to P only. That means you are going to take P value is true, false. Again P, true, false. What about P or P? We are going to get true, then false. That is P only. That means P and P is also P only. Next, or and or P and negation P becomes a OR value. If there is a P and P returns as a false value. Okay, false value. False or operation returns as a true, or it may be true. So true and or is also or only. Next, or P and negation P is a true value. True value. That is the equivalent to loss. Next, or and P and negation P is a false value. Or and false is false. Or true is true only. Next, P tends to Q is equivalent to us according to the conditional law. So, in the case of conditional law, P implies Q is a negation P or Q. Next, the same proportion you are going to apply the negation. This negation becomes a P or becomes and negation Q. This negation. So, at the time of solving the examples, we are going to apply the equivalent laws. Then, P tends to Q is equivalent to negation Q tends to negation P. Either you can write negation P or Q, or negation Q tends to negation P, depends upon the derivation of the conclusion. P implies Q tends to or is equivalent to, that is a P and Q implies or. P and Q implies or. Next, negation of P biconditional Q is equivalent to P biconditional negation Q. P biconditional Q is equivalent to P implies Q or Q implies P. That is the conditional laws. P implies Q is written as either P and Q or negation P and negation Q. These are called as equivalence formulas. There is 22 equivalence formulas are there, and 14 implications are there. We are going to apply all these implications as well as equivalent laws to derive the conclusion. Now we'll take some examples how the conclusion can be derived from the set of premises. What are the rules we are going to apply? I'll explain step by step. Now show that OR is logically derived from P tends to Q, Q tends to OR, and then P. Okay. So what are the set of premises? The set of premises are P tends to Q, first premise, Q tends to OR is the second premise, and P is the third premise. From these set of premises, what we are going to do, that is OR. If it is the last step is OR, is derived from the set of premises, then we can say that it is a valid inference. Then it is a valid inference. So what is, you can write what is the step, what is the implication number, then step number, rule, and what is the rule, whether it is a rule P or it is a rule T. It is a step number 1, write 1 in the flower braces 1. First premise is P tends to Q. P tends to Q is already exist in the set of premises. We can call it as rule P. We can call it as rule P. Next, right, if it is a new premise, give the new number as 2. So what is the next premise you are going to take? You take any premise. No need to follow any order. But our main aim is we need to derive the conclusion from the set of premises. So for that reason, second thing is I am going to take 2. It is a new premise, give the number as 2. It is also exist in the set of premises. We can call it as rule P. Next, from the first one and second one, that is 1, 2. And third step is derived. Rule 1, rule 2. Okay, what is rule 1? P tends to Q, and then Q. What is I number 11? I11 is P tends to Q derives Q. Derives Q. That is the rule number I11. So Q is derived. It is called as rule T. Why it is called as rule T? It is derived. How it is derived? From the premise number 1. From the premise number 2, it is derived. So we can call it as rule T. From where it is derived? Rule 1, rule 2, and I11, Q is derived. Next, P tends to Q is already used. P is already used. What is the leftover premise? Q tends to R. So 3 is already completed. Give the number as 4. Step number 4, Q tends to R. Q tends to R is present in the set of premises. We can call it as rule P. Rule P. Next, according to I11, that is already Q tends to R, then R is derived. So from 1 to 4. What is 1 to? 1 to is Q and 4 is Q tends to R. From these three, that is 1 to Q to then 4. Q tends to R is derived. That is, this is rule number 3. That is step number 3, step number 4 and then I11. Then we can derive R. That is the rule T. This is rule T. It is derived. How it is derived? From the set of premises called Q and Q tends to R. Then R is derived. So we can call it as a R. Then what is the conclusion? R is a conclusion. Then the conclusion is derived. R is derived from the set of premises. Then we can call it as it is a valid inference. But please remember, at the right side you have to specify the rules, whether it is a rule P or it is a rule T. If it is a rule P, how it is derived. If it is a rule T, you have to specify the what is the corresponding number. You have to specify and write the implication number. It is the good impression for the examiners to get good marks in the exam. Now let us take second example, how the conclusion can be derived from the set of premises. Show that S union R is to be logically implied from P and Q. P or Q, P tends to R, Q tends to R. Here there is a conjunction of premises. Okay, the first premise is P or Q, that is premise number 1. Next, second premise is P tends to R, that is premise number 2. Next, Q tends to S, that is the premise number 3. From these premises, what you are going to do? We need to derive the conclusion. S union R is the conclusion which is derived from the set of premises. Next, take the step number as 1. Apply the rule number 1, P or Q. P or Q is already exist in the set of premises. We can call it as rule P. We can call it as rule P. Next, again for the same rule, we need to apply the E1 and then E16. According to E1, you can write P tends to P or Q is to be written as negation P. Then from the U16, P tends to Q is derived as a Q. So apply the two things, E1 and E16. Then we can derive as a negation P tends to Q. Please observe the rules of E1 and E16. E1 is what is negation? Negation P is a P. Then what I1? Not I1, it is I1. Okay. So P tends to Q, we can rewrite it as a P and then E16. According to U16, P tends to Q is derived as a negation P or Q. According to E1 and E16, P or Q is written as negation P derives Q. It is derived from the set of premises. So we can call it as rule T. From where it is derived? From the rule number 1 is derived. What are the rules you are applied? E1 and E16. According to E1 and E16, it becomes negation P tends to Q. Next, step 2 is completed. Then next step is not 2, it is 3. Next, Q tends to S. It is already exist in the set of premises. It is already exist in the set of premises. We can call it as rule P. From the rule number 1, rule number 3. Negation P then Q. So, by default Q get cancelled. Maybe negation P tends to S. It is derived. So, it is derived. So, we can call it as rule T. From where it is derived? Step number 2 and step number 3. That is 2 and 3. I13. Rule I implication number 13. We can derive negation P tends to S. Next. Again for the same thing, we need to apply the E13 and E1. Just to change the parameter. Just change the parameters. 1, 3. So, in the place of P, we are going to take S. In the place of S, we are going to take P according to the E1 and E13. It is also derived from the rule number 4. It is derived means it is a rule number T. And from where it is derived? E13 and E1. So, that is called as a rule T. Next. So, what is the next preposition? P tends to R. P tends to R is a new premise. It is a new premise. Already 5 is completed. That's why the step number becomes 6. P tends to R. So, from the P tends to R is present in the set of premises. We can call it as P. P means rule P. P means rule P. Next, from 1, 3, 6. That means what is 1, 3? 1, 3 is the step number. Negation P tends to S. Again, P tends to R. From 1, 3, 6. Negation, PP cancel, we are going to get negation S tends to R. It is derived. So, we can call it as rule number T. From where it is derived, step number 5, step number 6 and implication number I13, negation S tends to R. Negation S tends to R. Then after 7th step, next step is still we need to simplify this expression. That's why 136 is repeated. Step number 8. According to the implication law, that is P tends to Q is implies negation P or Q. In the place of P, negation S is there. In the place of Q, R is there. According to this one, we are going to write it as a P. Negation P means S union. What is there in the place of Q? R is there. S union R. According to the E1 and E16, it is derived. From where it is derived? Rule number 7. Then E16, we are going to derive this rule. It is derived, that's why it is called as a T. S union R is a conclusion. It is a conclusion. S union R is derived from the set of premises. So, we can call it as a valid inference. It is a valid inference. Now, take one more example for better understanding of the rules of inference. Next, show that negation P tends to Q derives negation P. So, what is the conclusion here? Negation P is a conclusion. Negation P is a conclusion. How this negation P is derived? From these two set of premises. Premise number 1, premise number 2. Okay. So, take step number 1 again. That is a implication number 1, P tends to Q. P tends to Q is already present in the set of premises. We can call it as rule P. For the same set of premises, we are going to apply E18. So, in the case of P, we are going to take negation P. In the place of Q, we are going to take negation Q according to E18. It is derived. It is derived by applying the equivalent law of 18. Then we can call it as a rule T. Next. So, 1 is completed, 2 is completed. Next step number becomes 3. Then implication number is 3. So, negation P is applied. So, it is already present in the set of premises. We can call it as rule P. So, next from step number negation P, negation Q is present. What is the step number 1? What is negation Q is present on? Step number 3. So, negation P tends to Q, negation Q, both are gets cancelled. Then what is the remaining proportion? Negation P. It is not 7. It is a negation. Negation is written as like this. Okay. Or you can use this as a this symbol. Either you can use this tilde mark or this symbol to indicate the negation. So, negation P is derived from the what is step number 1 and 2 and 3. This is step number 2. Step number 3, it is derived. What we can derive? Negation P is derived. If it is derived, we can write it as a rule T and I11 implication number. What is the conclusion? Negation P is derived from the set of premises. So, we can say that it is a valid inference. It is a valid inference. So, what we have discussed up to now, what are the different types of rules of inference? What is rule P and what is rule T? When you are going to apply rule P and when you are going to apply rule T, we have discussed some example problems on rules of inference. What is the main aim of rules of inference? To check whether the conclusion is valid or not. There are two methods are there. One is a truth table method. Another one is a rules of inference. In case of truth table method, how can we say that it is a valid? The last column of the truth table derives the conclusion as a tautology. Then we can say that it is a valid inference. But in the case of by applying rules of inference, if the conclusion is the last step, then we can say that it is a valid inference.